So in this video, let's consider part 2 of the problem that we were treating in the previous video in this series, where we had the triangular region bounded by these three straight lines, f of y equals 1 over 2y, y equals 2, and y equals 0 and x equals 2. Now we wanted to find the volume of the solid formed by spinning this region first around the x-axis. And in the previous video, we did that using both techniques, method of washers and method of shells. So in this video, I would like to try to spin this region around the y-axis and to find expressions that would give me the volume for each of those solids of revolution. So once again, for method of washers, I'm going to start by getting a sketch that represents one particular cross-section of this region. So here comes my axes. Here comes my green line, which you can think of either as x equals 1/2 y or y equals 2x. Here comes x equals 2. And we found in the previous video that these two cross at y equals 4. So we are now spinning this region around the y-axis. So if I took a horizontal bar and spun that horizontal bar around, spin, spin, then a washer-shaped cross-section would appear as a result. So let's analyze what the area of this washer-shaped cross-section would be. Method of washers for around the y-axis. So in this case, method of washers, the area is going to depend on the vertical height on the y value where the cross-section is taken. In general, a washer has an area of pi big radius squared minus little radius squared. Now the big radius, the big x value of any of these cross sections is given by x equals 2. That is always the largest outermost function, 2 squared. The innermost x value is based on this green function here. The x value is equal to 1/2 the y value. So square the little radius. And then we can find the total volume by integrating from the smallest y to the largest y of pi times big radius squared, little radius squared, as y goes from 0 to 4. That would be method of washers for this region. Now, to sketch the idea for method of shells, we again get our drawing going. Here's green, and here's red. But this time, to fill up the region, I'm not going to spin around a horizontal bar. I'm going to spin around a vertical bar. I'm going to spin this vertical bar around, give it some depth, creating a cylindrical shell. So now I'm going to try and identify what would the radius of the cylinder be, r, and the radius of the cylinder is going to be based on the x value here of this function. Meanwhile, the height of the cylinder is going to be based on the difference between the y value of the green function and the y value of the bottom, which is consistently y equals 0. So the radius is just x, and the height of the cylinder is given by the y value on the green function, which was y equals 2x. So we can integrate from the lowest to the highest x value 2 pi times the radius times the height of the cylinder.